Our first example using photoelectric formulas are going to be kind of straightforward. Example 3 and 4 is where this formula starts to get a little bit harder. What students tend to have trouble with is actually building the formula. Then once they build the formula, then sometimes they make the odd mistake of different unit systems. Remember, we're using joule unit system and electron volt unit systems, so we have to make sure we have Planck's constant in for the appropriate unit system. And sometimes we also have a little bit of trouble building the photoelectric effect equation. I always start with the energy formula, which you'll see in examples 3 and 4. This first one's pretty straightforward. We're giving you the energy of the photon 1.42 times 10 to the negative 19. We're just looking for wavelength and frequency. So you have the energy 1.42 times 10 to the negative 19 joules. What we want to figure out is wavelength and frequency. Well, we could start with the E equals HF formula. Start with finding the frequency. It's equal to energy divided by Planck's constant. Since the energy is in joules, 1.42 times 10 to the negative 19 joules divided by Planck's constant in joules. This is off your data sheet, by the way. 6.63 times 10 to the negative 34 joule seconds. We'll end up with, if I punch in my calculator, 1.42 to the exponent negative 19 divided by 6.63 to the exponent negative 34. You get 2.14 times 10 to the 14 hertz. Now, to calculate the wavelength, you've got a couple ways to do this. You could use the energy formula again, or you can realize that C equals wavelength times frequency. So wavelength will be C divided by F. Doesn't matter which way you do this. The formula I chose, if I got frequency wrong, then I would get wavelength wrong. So if you want to use the E equals HC over lambda, go back to your original numbers, do that. But these formulas aren't that difficult to work with. So 3.0 times 10 to the 8 divided by 2.14 times 10 to the 14 hertz. I still got my original number in here. 3 to the exponent 8 divided by my previous answer, and I get 1.40 times 10 to the negative 6 meters. This is a pretty straightforward example, just using Planck's formula and basically the speed of light formula. We've worked with that in previous lessons. Nothing different here. We're just applying it to terminology of a photon. Remember, don't make the mistake of mistaking a photon for a proton. Photon is what we call a bundle of EMR energy.